Okay, so we've officially started. Hello to everyone on Zoom and everyone here, of course. I forgot to I told y'all I was going to do this, but I didn't send an email, and I forgot to post it here. But the answers to the sample tests are posted, right? But remember, we did decide to postpone the test until a week from today, so it's not Wednesday, it's next Monday, okay? And it's going to cover through this homework on angle measure, right? Which we've really already discussed. So we're actually already past that in the notes already. And that's just measuring angles with degrees and radians, right? And we're already on to discussing trigonometry. So we're well past this, and we'll be even further past that by the time of the test. But anyway, the sample test answers are posted, of course, along with the sample test. That's on the Blackboard page. So as I showed you guys last time or the time before, if you go to sample tests, right, that folder on the Blackboard page, there's the blank sample test, and then here is the there are the solutions to the sample test. Now, some of this that's on the original sample test, we're not going to cover on the test. So I cut off the solutions. I think it's at page 9, which is where we're going to stop. So it's problem 18, right? Okay. That's the last material for the test. So there are several other problems on the sample test which cover trigonometry, but that's not going to be on test number 1. So we'll save those for the next sample test and for test number 2, right? So so when you get to page 9 there, that's really it for what's going to be on test number 1. So if you're wondering why I don't have all the sample test answers there, that's it. But now these are solutions, right? So I've written out the solutions to the problems with a fair amount of detail, so to give you an idea, right, of how to go about solving the problems. That doesn't mean, though, that you have to write that much detail on the test, okay, right? But you do have to show work on the test, and that's important. So you have some steps on your test when when you're writing down your answers to justify your answers on the test. So be aware of that. And then don't forget, on the test, right, you can bring your survival card, your index card, which has to be a standard size index card, okay, like you can purchase, a standard size that you can purchase, and not a full 8.5 by 11 sheet, right, just an index card. And then you can write on that whatever you want, right, front and back. You can put the lyrics to your favorite song if you like on there, but because I'm not going to look at those, so or take those up. So that's up to you. But you should, as you're working on the sample test, which is really important to do, and when you're working on your homework, make sure that you are including things on your index card, right? So be thinking what you're going to put on your index card, and start filling that up. Okay, things that might be that you might need help remembering. If you're able to memorize everything, that's fine. You don't have to bring an index card. Okay, I mean, it's not required for use. It's just for you. And don't forget to leave a calculator as well, right? Okay. So, and you won't be able to use your phone. So if you need borrow a calculator, then make arrangements for that. All right. Test. Any style calculator will do for the test. Okay. All right. So there's a little reminder of things that are in our approximate future here, right? Next Monday for the test. Oh, yeah. So I forgot to remind you of this also. So we'll take the test in 2 different shifts. So if your name, if your last name begins with A through am I supposed to stop with M or N or L? But anyway, if it begins with, we'll say A through M, then you can come at 10 o'clock, to take the test. But if your last name begins with a letter after M, then you will come at like 11:15, and we'll start the test then. All right, so approximately 11:15 is when the second group will take their test. That's just to maintain our social distancing. All right, so that we're not all in simultaneously. Did everyone hear that online? So A through M come at 10 next Monday. So the test is in person, of course. And then if N through Z come at 11:15 and then take the test. Well, actually, Muhammad, it's slightly more than an hour, right? It's like an hour and 15 minutes. But the length of the test will be designed to, yeah, I'm not sure how many questions, but I always get asked that. I'm not sure. But the length of the test will be designed to fit into that time period. Okay. All right. So I've given the test in this format before, so I know how long the test should take, okay, for most people. All right, so don't go by the length of the sample test as a guide to the length of the test, right? Ahmad, is that what you're worried about? The sample test includes everything that I could think of, okay, as a review, all right, but the test may not include all of those things. All right, is it paper? No, it's paper, so it's written. It looks very similar to the sample test. Okay, it's printed. You're going to write on it and your solutions and your answers on the test, right? Including your work. That's important because I cannot. That's how I give partial credit, but it's also how I understand that you're doing the work. No multiple choice. Yeah, no multiple choice, Muhammad. Yeah, we don't. I don't like multiple choice. It's actually a valid test format, but I don't care. So no multiple choice. Yeah, it's all written. Okay. All right. So get ready for that, and just prepare by studying the sample test right and finishing your homeworks and reviewing your homeworks. That's how you prepare for the test. Don't forget, you can do the sample test in the Math Center. So if you want to take it to the Math Center, North 925 in the 1 main building, take it there and work on it there, and get the tutors there to respond to questions as you have them, right? Okay, let's see. I wanted to go back to the lines assignment, which was due on Saturday, because there were a couple of things that kept coming up, and so I wanted to make sure I answered them. So here's that homework. One of them was trivial. It was this last question on the water pressure. And so when you're typing in the formula for this relationship between the pressure and the depth, okay, some people were typing lowercase p equals, all right, because you have to read very carefully there to see that WebAssign wanted to represent the pressure by capital P, okay? So if you typed in lowercase p equals, then it counted you wrong. So if that was driving you crazy, then sorry about that. Just had to look at that really kind of carefully there. And another problem that's really important is like number 11. Okay, so and you'll see this is on the sample test. All right, so there's problem like actually 10 and 11. So these are really rather straightforward problems, but I did get questions about these. So since this is on the sample test, you really need to make sure that you know how to do this. Okay, all right, because it's really pretty easy to do. But this is something that's likely to be on the test because it's on the sample test. So, so let's look at these two. They're very similar problems, except in the first one, they're telling you find the equation of a line that goes through this given point 2,5 and is parallel to something. Okay, and then the second one is find an equation of the line that satisfies the given condition. So again, it goes through this point, but now they want perpendicular to another line, right? So here they're asking parallel, and here they're asking perpendicular. This first problem is a little bit trivial just because of the condition that they've given you. All right. So let me lower the screen here and see if I can find some. Open the notes, and so I can find a place to write. Okay. Keep in mind that point 2, 5, right? And this was parallel to the y-axis. Let me open the notes. Oops. You can see there we have a recall practice coming up. So let me get past that though. All right. So so we want the line that is that goes through this point 2, 5 and is parallel to the y-axis. Well, normally the way you would approach this problem is you would think since the line you're interested in is parallel to this given line, we would want to know what is the slope, what's the slope of the given line, okay? But in this case, the given line here is the y-axis, right? Which is vertical, correct? The y-axis is vertical, and vertical lines do not have a slope, okay? Vertical lines don't have a slope. So you really can't use the slope information to help you with this particular problem, all right? So if you think about what this line looks like, right? If you sort of imagine this, you can imagine this in your mind, but I'm going to draw here notes, right? It passes through the point 2, 5. Draw this up. So it passes through this point 2, 5 up here, right? Okay, but parallel to the y-axis means that it's vertical, and vertical lines don't have a slope. Horizontal lines have slope 0, okay, but vertical lines don't have a slope. So to write down the formula for this line does have a formula though, okay, but it's a very simple formula. It's just going to be of the form x equals to, and then whatever x coordinate is of all of the points on this line. Okay, so what is the x coordinate for all the points on this line? 2, right? So the equation for this line is very simple. It's just x equals 2. All right. The reason that vertical lines don't have a slope, right, is think about it. If you pick another point off of this vertical line, let's say the x-intercept here, right, which is obviously here at 2 on the x-axis. And if you tried to calculate the slope between those 2 points, you would end up with this meaningless computation, right? You would take the difference in the y-coordinates, right? Well, the y-coordinates here are 5 and 0, so we would take 5 minus 0, right? The y-coordinate at this point is 5, the y-coordinate at this point is 0. But then you would divide by the difference in the x-coordinates, which is going to be 2 minus 2, because both these points have the same x-coordinate, right? And so you end up with 5 over 0, which is undefined, right? So, you know, you can't do this calculation. You cannot divide by 0. So this line does not have a slope, okay? Vertical lines don't have a slope. But that's the only sort of line that doesn't have a slope, a vertical line. A horizontal line, on the other hand, does have a slope. If I draw a horizontal line across here, it does have a slope, but its slope is 0, okay? So horizontal lines, slope is going to be 0. Well, 0 is a number you can work with, right? So you can use all the same facts about straight lines that we use for other problems and apply them to this horizontal line. But unfortunately, since vertical lines don't have a slope, then that means we have to treat them a little bit differently than other lines. Okay, but their formulas are still easy to write down. It's just going to be x equal to number. Now, a more typical problem of this type would be find a line that passes through a given point and is parallel to some given line. All right, let's make up a line here for fun. Well, let's use the let's just make up a line here. So suppose they told you, I want the line that passes through this point, but it's parallel to this line. Okay. So I just made up that linear equation just as an example. All right. So there's nothing special about this linear equation. We know this is a linear equation, right? Because x and y are raised to the they're raised to the first power. All right. So we want a line that goes through this point parallel to this line. You could draw a picture of this line if you want to get an idea of, sort of what the picture is here. Okay. So you could graph this line and and then draw a line through this line through this point 2,5 that you think is roughly parallel to this one, but we don't need to go through all of those steps. Okay, we don't need to visualize this situation in order to answer the question. All we need to know is what is the slope of this line. Okay, so to find the slope of this line, just put it in slope-intercept form. That means solve it for. Okay, this one's really easy to solve for y. Just shift the 2x to the right-hand side. So we get y equals minus 2x plus 7. And that tells us immediately the slope is what? Yeah, almost. What? Minus 2, right? Okay. So be careful of your signs, right? Because you don't want to make sign mistakes on the test. So the slope there is minus 2, right? And then we're really done because we have the slope. And we know we want the line that goes through this point, okay? And now you can write down the equation for that line in point slope, right? This is slope intercept form, but we can write down the equation for the line that we're interested in here in point slope form. Remember, it looks like this, right? You have y equals to your slope, which is minus 2, x minus the x coordinate of the point that you're given, right? Which is 2. And then just add on the y coordinate of the point that you're given. So there it is. That's it. You can leave it just like that, unless you're asked some other question. You can just put it right in this form. So here's the line that goes through this point and parallel to this line. Since this line has negative slope, parallel, right? Okay. Since this line has negative slope, that means our line is going downhill from left to right, right? Remember, lines with negative slope are decreasing, okay? That may not be steep enough, but that line's going to be decreasing, okay? Let's see now, what was the second question, which is going to be very similar? We want a line that passes through this point, all right? So we're just given a point, but now we want it perpendicular to a line that passes through these other 2 points, minus 4, 4, and 0 and 2. Okay, and now you just have to remember the relationship between the slopes of perpendicular lines, right? Which is, as we proved in class, right? Those slopes are negative reciprocals of one another. Parallel lines have equal slopes, but perpendicular lines have negative reciprocal slopes. So again, we don't have to draw the picture, right? Do not have to draw a picture of this situation. We could if we wanted to. That makes you feel comfortable. You can, okay, but we don't have to draw a picture. We can just visualize it. Really don't even have to visualize it though, okay? In a way, you don't have to think about the picture at all. All you have to do is just figure out what is the slope of this line, right, that passes through these 2 points, take its negative reciprocal, and then use that to write down the equation for the line that passes through these 2 points, right? Do y'all write those points down so I can put them over here on the notes? Let's see what were they. We want the line that goes through what? -7, -8, and is perpendicular to the line that passes through what was it? -4, 4, and 0, 2. Okay. So let's calculate the slope of the line that passes through these 2 points, right? So that slope is going to be what? You take the difference in the y coordinates, right? So we can do 2 minus 4, but if you want to, you can do 4 minus 2. Either order is okay. Just make sure that you take the difference in the x coordinates in the same order that you do the difference in the y coordinates, okay? Otherwise, you'll end up with a sign mistake, which is going to be fatal here since we're going to be changing the signs, right? So I have what, 4 minus 2? No, I did 2 minus 4. So now in the denominator, I'm going to 0 minus a minus 4. And be careful about the signs, right? And 2 negatives in denominator, which is positive, right? So we have negative 2 over positive 4, which is minus 1/2. Okay. So the line that goes through these 2 points has negative slope, right? The line that we're interested in, though, has slope what? Well, take the negative reciprocal of this. So what's the reciprocal of this? Just flip it. So what do you have? 2 over 1, right? Or 2. And then you take that minus and you change it to what? Plus, right? Okay. So change the sign and take the reciprocal. And so you get this very easy slope of 2. And now, so easy, right? We have y is equal to 2 times x minus a minus 7. And then just add on the minus 8. You don't have to subtract the minus 8. And so there's the equation for your line. That's it. Okay. So so make sure you can do that on the make sure you can do this sort of problem on right for sure. Okay, these are very basic problems about lines. Are there other questions from that homework that was maybe throwing people off? Not drawing the graphs, because I know that's sometimes that graphing widget is hard to. Of course, you won't have a graphing widget on the on the test, right? But on the test, as you see on the sample test, may be asked to graph by hand. So if you're asked to graph a line by hand, make sure you practice that on the sample test so you do that. Okay. So that's just a matter, it's pretty easy to graph a line, right? Because there's only one line that passes through any 2 points, correct? That's just an axiom of geometry. So if you can find 2 points on the line, then all you have to do is draw a line through them. You can find 2 points on the line pretty easy, right? By using formula, picking x coordinates, right, and find the matching y value, or vice versa, pick the y value and find the matching x value. Okay, so a couple of points on the line is all you need to graph a straight line. So make sure you practiced graphing lines by hand, right? Okay, as on that sample test before you come for the test. That's a question that for some reason is missed a lot. Okay, and I think it's just lack, but that's easy. So I think it's just lack of paying attention to that skill. Okay, so because you've probably done it with the widget in the homework, right? So you're not used to doing that by hand, but on the test you have to do it by hand. Okay, questions there? All right, I didn't check the scores. Did y'all do that? Did y'all finish that? Not everyone's jumping up and saying this. Okay, now you're making me nervous. All right, now I think it's too late now to request an extension for the lines homework if you missed the due date, which was Saturday night, right? Okay, so but in general, you can if you do it within 1 day, you should be able to get the extension automatically. Okay, so but you have to do it quickly. So right over the due date, you can't be waiting for several days to request the extension. You do it soon. Okay. Okay. All right. Well, let's stop talking about that and let's go back now to our notes. And I gave away, right, that we have a recall practice. So let's look at this. So this isn't lines, right? This is trigonometry. And so just to remind us of the trigonometric ratios, I've drawn there for you a right triangle. This is a right triangle. Hope that's clear from the picture, but I can make it explicit by putting in a little box there, which indicates that that's a 90-degree angle down there in the lower right-hand corner, right? So that's definitely a right triangle. And then using that right triangle in A there, I just want you to find the sine, the cosine, and the tangent of this angle theta. So this is just seeing if you can recall or find in your notes, right? Remember the definition of those three trigonometric ratios, right? Sine, cosine, and tangent. And you may have to use the Pythagorean theorem briefly here, right? To find the length of the hypotenuse. Okay, you guys at home too also do that for me. While y'all are doing that, I'm gonna pass out some graphing paper for the class because you have to draw some angles today. So if you're at home, make sure you have something to write with. Yes, Ahmad, I think that's right, right? You can leave your answer in exact form, right? You don't have to get any sort of decimal approximation. So your answer may involve a square root, that's fine. You can just leave it in your, just leave that in your answer. I always forget which one. Well, that's really important. So look at the picture. It's kind of obvious from the picture. Okay, so just for A, did y'all remember the definition of the ratios? So that's something to work on memorizing if you haven't memorized that yet. So in general, when you're computing sine of an angle from a right triangle, right? What's the basic definition of sine? It's what? Which side over which side? Yeah, it's the opposite side over the hypotenuse, right? Okay. And then for cosine of theta, that's the adjacent side, right? Over the hypotenuse. And then tangent of theta doesn't involve the hypotenuse. That's what? Opposite over adjacent. And then if you can remember those three ratios, then the other three, remember, are going to be reciprocal. So, but we'll get to those in just a second, right? So in this particular situation, right, to compute sine of theta, I want the opposite side, Ahmad, which is 5, okay, because it's across from theta, right? Okay, so as who mentioned that, Christopher? So you have 5 there over, but you need to compute the hypotenuse, correct? Right? So that means we're going to have to use the Pythagorean theorem since I didn't fill in the hypotenuse here. So according to the Pythagorean theorem, the hypotenuse, let's call that C, our favorite name for the hypotenuse, right? C squared is going to be 5 squared plus 7 squared. And so C squared is 25 plus 49. Too bad that doesn't come out to be 64 because that would be a perfect square. But instead it comes out to be 74, which is not a perfect square, right? And so we get the hypotenuse is square root of 70, all right? And I don't think even by hand there's any way to even slightly simplify square root of 74. So just have to leave it like that unless you want to write down a decimal approximation for a square root of 74. So anyway, we get here it is. The sign is exactly there, 5 divided by square root of 7, right? And then cosine, right? Easy to compute. That's the adjacent side here, which is 7, because that is the side which touches the angle, right? Okay, so that's the side that's adjacent to theta. So we get 7 over square root of 74. And then for tangent, that's really easy because it doesn't involve a hypotenuse. Sometimes that makes tangent really convenient to use in practice because it doesn't involve the hypotenuse at all. And so you just get opposite, which is 5 over the adjacent, which is 7. All right, so 5/7 there for the tangent. Now, for the other 3 ratios, right? These are the reciprocal trig ratios. So you just have to memorize this. So, so you've got to remember that cosecant of theta is the reciprocal of the sine. So it's 1 over the sine of theta, okay? And so you just take the, you just flip the sine to get the cosecant. So cosecant of theta is going to be square root of 74 over 5. And then secant is the reciprocal of the cosine. So secant is 1 over cosine of theta. And so that's going to be square root of 74 over 7, right? And then it's pretty obvious, right, that cotangent, just by the name, is the reciprocal of the tangent. And so that's 7 over 5, okay? So from a right triangle there, it's pretty easy to, from a right triangle there, right, it's pretty easy to discover the, and write down the trig ratios. Let's use that, did y'all remember those? So if you don't, if you haven't memorized them yet, then now's the time to commit them to memory, okay? Many times we'll be computing trig ratios using a calculator. So these basic definitions for the trig ratios are not always that crucial to us, but at times, especially in applied problems, we really need to remember where what the basic definitions for sine, cosine are, right? Where they come from in terms of right triangles. All right, now, and speaking of knowing these definitions for the trig ratios, let's go back to where we left last time, and that is we were trying to find the sine and cosine and the tangent, and then, of course, that would also tell us the cosecant and the secant and the cotangent for the special angles. So the special angles are this just collection of angles that we use frequently in practice, and so those are 0 and then 30 degrees, which is the same as pi over 6 in radians, 45 degrees, which is the same as pi over 4 in radians, and then 60 degrees, twice 30 degrees, which is the same as pi over 3 in radians, and then also pi over 2, okay? So those 5 angles are what we refer to as the special angles, just because we use them so frequently, and those are ones that you really need to memorize: sine, cosine, especially sine and cosine, or those 5 angles, okay? You need to just have them committed to memory because we use those angles so frequently. Now, last time we had discovered the ratios for pi over 4, 45 degrees, okay? And so we wrote those down, and there they are, okay? So sine of 45 degrees, again, remember that's pi over 4 in radians. That was square root of 2 over 2. Cosine is also square root of 2 over 2. So that really makes a pi over 4 really a useful angle. And tangent is easy, it's just 1, okay? So tangent of 45 degrees is just 1, all right? And then a little bit less important, because you can derive them if you know these 3 ratios are the cosecant, the secant, and the cotangent for pi over 4, 45 degrees. Notice it's square root of 2, square root of 2. Okay, so we derive those trig ratios from looking at a picture of a right triangle that had a 45 angle in it. Now a little bit, and that was actually a pretty easy picture to draw. So these trig ratios were easy to discover. A little bit harder, but still not difficult, are finding the trig ratios for 60 degrees and 30 degrees, okay? So remember, 60 degrees is pi over 3 in radians, and 30 degrees is pi over 6 in radians, all right? So we're going to discover now what the sine, cosine, especially the sine and cosine, but then the other trig ratios are for 60 degrees and 30 degrees, okay? All right, let me show you how we do this. We're still going to draw some right triangles here, but I have to draw the right triangle just right so that it makes these computations easy. So here's the picture that I'm going to draw, okay? I'm going to take an equilateral triangle. So an equilateral triangle, remember, is a triangle where all 3 angles are the same, okay? So in an equilateral triangle, if all 3 angles are the same, that means all 3 angles have to be 60 degrees, right? Because all of the angles in a triangle must add up to 180. So if you have a triangle where all the angles are equal, then they all have to be 60. Okay. All right. So that's what I've drawn here is an equilateral triangle. That's this big triangle here. All the angles have 60 degrees. But I also chose the equilateral triangle so that the sides have length. Okay. Doesn't matter if it's 4 inches or 4 feet, length 4 units. Okay. So I have an equilateral triangle. The sides all have length 4. The angles are all 60. And now I'm going to position that equilateral triangle on top of x-axis, right, like you see in this picture. But I'm going to draw it so that half of the triangle is on the positive side of the x-axis and half the triangle is on the negative side of the x-axis, just like in this picture. Okay. All right. Well, when you do that, of course, notice that the triangle gets kind of split into, the equilateral triangle gets split into 2 right triangles, right? Because the y-axis is going to split the triangle into 2 right triangles. So you have the right triangle on the left and you have the right triangle on the right, okay? So let's look at this right triangle and see what we can figure out about it, okay? Well, obviously, what's this angle in this right triangle, the right triangle on the right? This angle is obviously what? 60, right, okay? This is this obviously is a right angle, right? So this is 90 degrees. And then the angle at the top here of just the right triangle portion is going to be 30 degrees, right? Because that's half of the 60 degrees in the original big triangle. Okay, so this right triangle on the right here, notice that's a 30, 60, 90 right triangle. Okay, got one angle with 30 degrees, one angle with 60, and then of course it's a right triangle, so it has one angle 90 degrees. Right, now that means now we're kind of in good shape, right? Because now we have a right triangle, and one of the angles one of the acute angles in the right triangle is 60 degrees, and the other one is 30 degrees. So that's exactly the situation that I'm looking for, because I'm trying to find out what is the sine of 60 degrees. What is the cosine of 60 degrees? What is the sine of 30 degrees? What's the cosine of 30 degrees, right? So now I've got this nice right triangle drawn where I can start trying to figure that out. And I even know more, right? Okay, because I know what the length of the hypotenuse is, right? So that's great. That is 4, because remember, my original equilateral triangle, I drew it so that all the three sides had length 4. So I know this is 4. What's this side? 2, because it's half of that original 4, correct? Right? Remember, this full side has length 4, but by the way, I've got the triangle positioned right. This now must have length 2. So here we have 4. This, remember, now is length 2. And now I got to figure out what this side is, right? Okay. So the side from the x-axis up to the tip of the triangle. Now I can do that using the Pythagorean theorem, though, right? Okay. So let's call that length b here. So let me just label it b. So that's the length of this. That's the height of this triangle, right? That's the length of this side. So what do we know about b? If we take 2 squared plus b squared, that's going to give us 4 squared, right? That's just the Pythagorean theorem. So this side squared plus b squared is going to be the hypotenuse 4 squared. Well, so we have 4 plus b squared equals 16. So it looks like b squared is equal to 12, which means that b is the square root of 12. And you can write 12 as 4 times 3. You can also write it as 2 times 6, right? But it's convenient to write it as 4 times 3 because 4 is a perfect square. So you can extract the square root of 4 and you get what? 2 times the square root of 3? So there's the length of b. It's not a perfect square. It's got the square root in it, but it's 2 times the square root of 3. Now see, now you're done, right? Okay. Now we can start writing down all of our trig ratios. So what's the sine, for instance, of 60 degrees? And remember, 60 degrees is pi over 3 in radian. So sine of pi over 3 would be what? So there's the 60 degrees, right? What's the opposite side? 2 over the square root of 3, right? And what's the hypotenuse? 4, and you can divide 2 into 4, and you get square root of 3 over 2. So there it is. Okay, there we figured it out. There's the exact value for sine of 60 degrees. It's square root of 3 over 2. Sine of pi over 3 is square root of 3 over 2. See, there's something for you now to memorize, okay? Because pi over 3 is a special angle, and you've got to remember the trig ratios for the special angles. So sine of pi over 3, square root of 3 over 2. I'm going to give you all a hint of how to remember these values. Okay, we just so you're not just having to remember numbers at random. I'll show you a little trick for in a moment here for how to remember sine and cosine for the special angle. What's the cosine then of 60 degrees? So which again is the cosine of pi over 3. So let's see that's the adjacent side here, which is 2, right? Divided by the hypotenuse is 4. Oh, there's a nice number, 1/2. Oh, that's nice. So it just came out to be 1/2. What about the tangent? So that is let's see what the opposite over the adjacent. So we have what? Yeah, 2 square root of 3 over 2, which just simplifies to what? Square root of 3. Okay, oh, so that's pretty easy number also, sort of, to just square root. And again, now remember, you simply have to take the reciprocals of these numbers to find the cosecant, the secant, and the cotangent, right? So you just flip these values to get the cosecant, secant, and cotangent for pi over 3. Now, from the same triangles, right, you can also now find the sine, cosine, and tangent of 30 degrees, right? And remember, 30 degrees is the same as pi over 6. So what's the sine of 30 degrees? Is that 1/2? Yeah, now remember, we're looking at 30 degrees, right? So the opposite side is what? 2, and the hypotenuse is 4. So we get 2 over 4, which is 1/2. So there's a half what's the cosine of 30 degrees? So cosine of pi over 6. Well, that's the adjacent side, B side, right? Divided by 4. So you have 2 square root of 3 over 4, which is the square root of 3 over 2. Okay. So notice that for 60 degrees and 30 degrees, you just interchange sine and cosine, right? Okay. Just interchange the sine and the cosine. What's the tangent now for 30 degrees? So opposite. No, I'm sorry. Yeah, opposite over adjacent. So what do we get there? That's right. 2 over 2 times the square root of 3. The 2's divide out, so you get 1 divided by the square root of 3. Normally, you'll see that written as square root of 3 over 3. So instead of seeing it written as 1 divided by the square root of 3, you see it often written as square root of 3 divided by 3, which is the same number. And then again, just invert these to get the reciprocal trig ratios. So there we've got it. There we know now the sine and cosine for the special angles except for 0 and 90 degrees. Now that's a little bit of a mystery. Okay, how would we compute sine and cosine for and the other trig ratios for 0 degrees and for pi over 2, 90 degrees, because those angles are not going to be in a right triangle, right? So you may be wondering, why do we even bother to define sine and cosine for 0 and 90 degrees? Well, we really haven't come to that yet, okay? But they do have trig ratios, okay? And they're included in this table, okay? I'll show you how they come about coming up here soon, all right? So here's the table. This is in the notes. The special values for the, I'm sorry, the, kind of said that backwards, okay? It's the, well, don't want to reinterpret their table. But here's the sine and cosine for the special angles, all right? 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, okay? And the reason I circled 0 and 60 degrees is, again, it's a mystery as to how these trig ratios come about, because you cannot embed these angles and compute the trig ratios in a right triangle, okay? So, so there's a little bit of a mystery up until now as to why sine of 0 or cosine of 0 is what it is, okay, or why sine of 90 degrees or cosine of 90 degrees is what it is. All right, so you see those. So for sine, okay, there's the special angles. So sine of 0 is 0 for some reason, all right, and then sine of 30 degrees is 1/2, right? Sine of pi over 6 is 1/2. Sine of 45 degrees, square root of 2 over 2. Sine of 60 degrees, square root of 3 over 2. And then finally, the sine of 90 degrees, pi over 2, is for some reason 1. All right, let me show you now how it's kind of easy to remember this sequence of values. All right, notice that the format for all of those sine values is, you can write it down all in the same format. Think of it as a fraction where the denominator is always 2, okay? So just think of these trig values as a fraction where the denominator is always 2, right? It's the numerator that's changing here. Now, how do we get the numerator? You always take the square root of a number in the numerator, okay? And you just count up from 0 to 4, okay? So for sine of 0, you're going to have square root of 0 divided by 2. Of course, what's square root of 0? square root of 0, 0, right? Okay. So you get 0 divided by 2, which is 0. So sine of 0 is 0. Okay. Now, what about for 30 degrees? You get square root of 1. See, it goes up 1. Always divided by 2. So square root of 1 divided by 2. Of course, what's square root of 1 now, Robbie? 1, yeah, 1/2, right? Okay. All right. For 45 degrees, it's square root of 2 divided by 2. For 60 degrees, square root of 3 divided by 2. And then for 90 degrees, same format. You have square root of 4 divided by 2. But what's the square root of 4? And 2 divided by 2 is 1, right? Okay. So if you can just remember, it's always a square root divided by 2. And we count up square root of 0, square root of 1, square root of 2, square root of 3, square root of 4, always divided by 2. That's how you can easily remember the sign of the special angles. The special angles, again, remember 0, 30, 45, 60, and 90. Okay. Cosine is just backwards. Start with square root of 4 over 2 and count down. Okay. So notice cosine of 0 is 1. Square root of 4 divided by 2. And why that is, again, we haven't explained yet. Okay. Because you cannot have a 0-degree angle in a right triangle, right? But there's a reason for that. And then for 30 degrees, it's square root of 3 divided by 2. For 45, square root of 2 divided by 2. For 60, it's square root of 1 divided by 2. But square root of 1 is 1, so you get 1/2. And then finally, for 90 degrees, cosine is square root of 0 divided by 2. But square root of 0 is 0. 0 divided by 2 is 0. Right? So cosine of 90. Now, what about for tangent? How can we memorize that? Well, all right, the easy thing is to recall this identity. Tangent is sine divided by cosine. Okay, that's actually an important identity that we didn't show yet. But if you take the sine of an angle and divide it by the cosine of an angle, that always gives you the tangent. Why is that the case? Well, remember, what's the definition of tangent? It's opposite over adjacent, right? You can write opposite over adjacent, though, in this way. You can write it as opposite over hypotenuse divided by adjacent over hypotenuse. Because the hypotenuse is there, whoops. The hypotenuses will, let me scroll down here. The hypotenuses in that, in this complex fraction will cancel. These two hypotenuse values will cancel. And you'll just get opposite over adjacent. But what's opposite over hypotenuse? It's sine. What's adjacent over hypotenuse? It's cosine. So tangent is always sine divided by cosine. So if you can remember just sine and cosine, then you can calculate tangent easily because it's just sine divided by cosine. So that's how you can fill in this table. Just take the sine value divided by the cosine value, and you can get tangent. Of course, how do you get the cosecant, secant, and cotangent? Just do what? Take the what? Take the reciprocal, right? Okay. So just take the reciprocals, and you can get cosecant, secant, and cotangent. So the only thing you really have to remember out of this table is sine and cosine. Okay. Tangent you can compute because it's sine divided by cosine, and these other three trig ratios you can compute because you just take the reciprocal. Okay, of either the sine, the cosine, or the tangent. I think I can remember that little scheme there. Okay. All right. I'm going to pass out now a table for you, and so for people in the class, and this has this same chart that's in the notes, but it's in an expanded version, okay, of this chart, because we're getting ready shortly here to start computing sines and cosines and tangents of angles larger than 90 degrees. Okay, all right, because that's something that we do frequently. Believe it or not, you can compute sines and cosines and tangents, trig ratios for angles bigger than 90 degrees. So this chart is a little bit expanded, okay? But the top is highlighted. It's just the same that's in the notes, all right? There's 2 pages to this, so there's other things in this handout. This handout now, for those people online, The handout is contained on the Blackboard page. On the Blackboard page. Forgot where though. If you go to, I think it's under class notes and videos. Look down, there it is. Okay, it's in that a long list of class notes and videos. There it is. This chart that I'm passing out to the class. Okay, so you can get a copy of it also. All right, from the Blackboard page. And this is just for reference. It's just a chart that has information about sines, cosines, and tangents of angles, right? It's just an expanded version of this table that's in the notes. All right, so I'm going to pass that out. Okay, well, let's look at some applications of trigonometry so we can see how all this came about. So why all this interest in the trig ratios anyway, right? So why was all of this knowledge developed? And initially, the reason it was developed was to solve problems in geometry that show up in lots of different disciplines. Let me show you just an abstract version of such a problem, and then we'll look at an applied version. So here we have a right triangle, and notice that some values are included in the right triangle, but some of the values are missing. So in this right triangle, we know that this angle is 30 degrees, which is the same as pi over 6, right? Okay. And we know that the hypotenuse of the right triangle is 12. It's got to be clear that this is a right triangle, though, right? Because we're going to use trig here, and that only applies to right triangles. So that's indicated, right? But this is a 90 by the little box drawn here. So we do have a right triangle. And what we want to do in this problem is what's called solving the triangle. That means we want to fill in all of the remaining missing values there in the picture, right? So we want to know the length of all the three sides and the size of all of the angles. Okay, so we want to find A and B, the lengths of those two sides, and then also the value for beta there, which is that third angle. Well, the value for beta is really easy, so we don't need trigonometry for that, right? What's beta here? 60, right? Okay, since this angle is 30 degrees, then beta must be 60, right? So we have a 30, 60, 90 right triangle. Okay. All right. So that was easy. But now what's a little bit trickier, of course, is figuring out A and B, right? So you cannot do that now using the Pythagorean theorem, correct? Okay, because you can certainly apply the Pythagorean theorem to this right triangle because the Pythagorean theorem applies to all right triangles. So you can write down the Pythagorean theorem, and you would have a squared plus b squared is equal to 12 squared, right? But you cannot then solve for a and b because you've got this one equation, but you have two unknowns in the equation, right? So you're not going to be able to figure out what a is or what b is from the Pythagorean theorem. Okay, so we have to go beyond the Pythagorean theorem to solve this right triangle. That's where the trig is helpful. All right. However, what we can do is, I mean, we can write down the Pythagorean theorem. It's not helpful, what we can also do is write down the trig ratios for the angles in this triangle, right? Let's focus on the, did everyone sign that? Okay. Oh, yeah. All right. So let's focus on the 30 degrees, but we can use the 60 also. Okay. 30. And let's write down the trig ratios for the 30 degrees based on this picture that we've got, right? So let's start with sine. So we know that the sine of 30 degrees, right, is what here in this picture? It's a over 12, right? Yeah, you don't know what the opposite side is, but it's called a. So you just write down a there, and then, but you do know the hypotenuse is 12. Now, we could figure out a, right, if we could solve this equation, if we could solve this equation for a. Now, you might protest here, right, that how is this equation any easier to solve than this one, where in the Pythagorean theorem, right, where I had two unknowns, okay? So don't I have more than one unknown in this equation as well? And the answer is no, you don't, okay? You don't know a, right? You don't know that value. You do know 12, but you do know the sine of 30 degrees. That is not an unknown to us any longer, right? Okay, because we just calculated that a moment ago. So we know this value, it's not an unknown value. So we can fill that into the equation, and then we have just an equation with one unknown, right, that we can solve. So you see, we can figure out what a is. Before we do that, you know, you can also write down a cosine of 30 degrees, right? That's b over 12. That's the adjacent over 12. Or you can also write down the tangent of 30 degrees, which in this picture would be what? Yeah, that's a over b. Notice this last equation is not very helpful to you, okay? All right. The last equation is not very helpful to you. It does have two unknown values, all right? So this last equation is about as bad as this Pythagorean theorem equation is, right? Because this has two unknown values in it. But the tangent of 30 degrees is not an unknown value that we calculate. All right, now, well, let's go back here then. So what did we get for sine of 30 degrees just a moment ago? 1/2, right? Okay, that was in our table, right? Okay, there's sine, right? There's 30 degrees. Yeah, the sine of 30 is 1/2. Okay, but remember now you can reproduce that, correct? So you have a scheme now for reproducing that. Remember, you're thinking sine of 30 degrees. Okay, so let's start at 0. Sine of 0 is square root of 0 over 2. And then we go up to the next special angle, which is 30 degrees, right? Okay. And sine of 30 degrees, oh yeah, that's square root of 1 over 2, right? Okay, which is 1/2. So if you remember that that scheme for reproducing the table, right? Then you don't really have to memorize the table, although you will, because you'll be using these special angles a lot. Then you can remember that sine of 30 degrees is 1/2. So we have 1/2 is equal to a over 12. And now we just have to solve this equation for a. Oh, that's a proportion, so I can cross multiply here, right? So I have 12 times 1 is equal to 2 times a, or that means a is equal to 6, right? So see how easy that was? So now you've almost finished solving the triangle, because now you know that the value of 6. Now we know the value of a. You know, for instance, if we wanted to, we could use this equation to solve for b, because we could fill in that a is 6. And now this equation just has one unknown in it. But that's not really necessary to go all the way down to this equation, because we have this second equation, right? which already involves b. So that says the cosine of 30 degrees is b divided by 12. All right, so what's the cosine of 30 degrees? Square root over 2. Remember, how can you remember that? Well, cosine, let's see. For computing cosine, we start with square root of 4 divided by 2. Cosine of 0 is square root of 4 divided by 2. Then you go up to 30 degrees, the next special angle, that's square root of 3 divided by 2. For cosine, you're counting down, okay, in the numerator. So we have square root of 3 divided by 2. That's it, all right? All right, so let's put that in here. Let's see if I've got some room. So we have square root of 3 divided by 2 is equal to b over 12. And now let's try cross multiplying again. So I have 12 times the square root of 3 is equal to 2 times b. Divide by 2, so you get what? B is equal to 6 times the square root of 3, whatever number that is. 6 times the square root of 3. A little bit over 10, huh? 10.39, okay? So if you don't need a decimal approximation, Amanda, for some reason, many times you will, but if you don't need a decimal approximation for b, you can just leave it as 6 times square root of 3. That's the exact answer, right? Okay. But if this were in some sort of application, you probably have to give a decimal approximation. That's right, okay? You know, if you were trying to, if this were a measurement, trying to cut aside that length, you have to know what 6 times the square root of 3 is, right? To cut that length properly. Right. That's called solving a triangle, and that's really the reason trigonometry was invented. Now, that's not the only uses for trigonometry any longer, okay? But these were the original ancient uses for trigonometry, and we still use trigonometry a lot for solving triangles, okay? Because right triangles come up frequently, right, in all sorts of situations. Let's try another solving problem, okay? This one looks very similar, except we just fixed up sides a little bit. So here we have a triangle. Let's see, we have an angle. The measure there is 1.30. So that is in radians, all right? Okay. So we've switched to radian measure here. And let's see if we can figure out the other sides of this triangle and also that angle beta. All right, now y'all are gonna have to help me with beta because that's a little bit trickier here in radians. So what is the size of beta? I don't need trigonometry, right? Okay, I just need basic geometry. What do you know about those two angles in a right triangle? They have to add up to what? These two, not including this one, have to add up to what? 90. They have to add up to 90 degrees, right? Okay. But in radians, what's 90 degrees? Pi over 2, right? So let me write it down here. So you know beta plus the 1.3, that has to add up to pi over 2, right? So that means beta itself is going to be pi over 2 subtract 1.3. That's actually the exact value for beta. Okay, pi over 2 minus 1.30. That's approximately what, though, on your calculator, to a couple of decimal places, just take pi divided by 2, 0.27. Okay, so a beta there in radians is about 0.27. Okay, now let's find the lengths of the sides. All right. So let's start with side A. So what you want to think about here is what's a trig ratio I can use that involves side A plus an angle that I know, right? Well, I know this angle 1.30, correct? So probably want to use that angle, although we could use beta, but let's stick 1.30, right? So what trig ratio 1.0 involves side A? It could be the if we wanted to sort of go down the long path, we could think of cosine first, right? Okay, because side A here is the adjacent side to 1.30, right? Okay, and oh, cosine, that involves the adjacent side, right? So you might think, okay, I'm going to write down cosine of 1.30 is equal to my adjacent side A over my hypotenuse, which here is C. But that doesn't get you very far, right? Because why? Yeah, you have two unknowns in that equation, right? So you can't solve that equation with two unknowns, okay? So back to the drawing board here. Let's think of another trig ratio. So what else involves the adjacent side? There's only one other possibility here. Well, obvious possibility, right? Tangent? There you go, right, okay? Because the tangent of 1.30 is going to be what? The opposite over the adjacent side. Oh, yay, because I know the opposite side, correct? Okay, opposite side is 10. So in this equation, there's only one unknown. Tangent of 1.30 is not an unknown. Okay, that is not an unknown. The only unknown here is A. Now, why is this not an unknown? 1.3 is not a special angle, so I don't have to memorize, thank God, tangent of 1.30, right? So why is that not unknown to me? What the tangent of 1.30 is? What makes it known to me? What? Yeah, the calculator, obviously, right? Okay, yeah. All right. So the calculator knows, and therefore you also know what the tangent of 1.0 is, right? So here you're going to have to use your calculator to compute this trig ratio. Make sure the calculator is in radian mode because 1.30 is measured in radians, right? Okay. So just punch in 1.3 there. Make sure you're in radian mode on your calculator. Your calculator will have a tangent key on it. So compute that tangent and you come out to a pretty nice value there. It's just what, 3.60 to a couple of decimal places. So we have 3.60 is 10 divided by A. And now got an easy equation to solve, right? Just cross multiply again, right? So A times 3.60 is equal to 10. So divide both sides by 0.6. And that turns out to be, if I can do that, 2.78 about. Is that what y'all got? Okay, so approximately, so I'm going to write the little wavy line there for approximately 2.78. All right, so we're almost finished, right? All we have to figure out is the hypotenuse. If you want to, at this point now, you can switch to using the Pythagorean theorem because you now know the two legs, right, of this right triangle. So you can use the Pythagorean theorem to figure out C. But let's not use the Pythagorean theorem because this is already an approximation, right? So so let's go back to using trig to find C. Okay. So what trig ratio could we use there to find C? Sine? Yeah, that would work well, right? Why, Robbie? You have opposite, and this is going to, this obviously is the hypotenuse, right? Okay, so you know that the sine of 1.30, which again, the calculator is going to tell us here, is 10 divided by C, right? All right, so according to the calculator, what is the sine of 1 point? Is that it? I get a different number. Am I doing something wrong? What now? Or just the sine of 1.3? Oh, I see. We got 0.96 approximately. So we have 0.96 is 10 divided by C. So now you can cross multiply again, right? So you have 0.96 times C is equal to 10. And then just divide both sides by 0.96, right? So it comes out a little bit bigger than 10, right? Because you're dividing 10 by a number a little bit less than 1. So get a number a little bit bigger. All right, so it's 10. Great. So there's our solved triangle. Okay. All right, let's put this in a little bit more practical setting. All right. So here's going to be our problem for you guys. All right. So let's take a break. You can work on it if you want to, but we're going to take a break and then come back and look at the solution to this one. This is a much more practical, right? Okay. You're wondering how people discover the size of things, okay, the height of things. Here's an example of that, right? Just a simple application of trig. All right, so let's take a break here till about 11:30, and then we're going to come back and solve this one, and then go on and talk about what about angles bigger than 90 degrees, right? Here. With this, let's resume with this applied problem, right? So we're trying to measure the height of this giant redwood tree. All right, so we're not going to be able to climb up there to the top, right? So let's see if we can, so we want to measure that from the ground. So how can we do that? And so in the, you really don't need the sun involved in the problem here, but but the way they're describing it is a little bit more elaborate than is necessary. So there's the tree, and the tree casts a shadow, right? Okay, here of 532 feet, right? So the shadow is along the ground, so you can measure the shadow, right? Okay, that we can measure. And so this shadow from the base of the tree here to the tip of the shadow is 532 feet. Now, we also, from the ground, can measure the angle of elevation from the tip of the shadow to the top of the tree. We have instruments to do that, right? That's a surveying sort of problem. So we can measure this angle of elevation here, and it turns out to be 25.7 degrees, okay? And so then what's the height of the tree? That's the question, all right? So, so we can also, the shadow is really irrelevant. We could measure the height of the tree just by stepping away from the base of the tree a certain distance, right? A distance that we can measure, and then measuring this angle of elevation up to the top of the tree, which we do just with surveying instruments, right? So, so the sun there is really kind of superfluous to the problem. So anyway, we want to know what's the height of the tree, right? That's the question. So can we use trigonometry there to determine the height of the tree, right? Okay. All right, so that's the question for everyone, for you guys at home also, right? What is the height of that tree? So what trig ratio can you use, right? Okay, to determine the height of the tree, and then once you've figured that out, right, what is the height? Okay, you'll need your calculator, right? Fortunately, we have an angle here. Well, I don't know if it's fortunate, but maybe it's a little bit easier. We have an angle here that's measured in degrees. All right, so if you're using your calculator, make sure your calculator is set to degree mode, right? Okay, not to radian mode. All right. So hopefully on your calculator, you know how to switch both back and forth, right, between the two. All right, so try that one. I'm just going to go around the class and look and make sure everybody's doing the right thing, but it's pretty straightforward if you think about it correctly. And then we'll get someone from the class to tell us that. Well, Mohammed, I don't know what your question referred to there. You can ask me again. You can ask me again after class. All right, so you guys at home also work on it. That's the right taking out. So sine. Okay, that was good. All right. So I need someone on Zoom, right? Okay, to maybe explain to me how to go about solving this. All right, and guide me through the steps. Who on Zoom wants to help me with this? So I got 15 guys out there who wants to guide me through this, or do I get to pick someone? Mohammed, can you help me? Mohammed Sarwar, can you help me?
Oh, I'm still working through it.
Okay, well, all right. So, but still, you can help me. All right, because Mohammed, look, you've got this picture, right? Okay, and you have this angle, and you're looking for this length. So, in trig language, in terms of this angle, which would this side be? Right. I mean, you've got the hypotenuse side, you got the adjacent side, right? Okay. For this angle, what would this height be? Which side would that be? Mohammed. See, for that angle, well, which side is this with respect to that angle? Which side is the 532?
I don't really remember. I got here kind of late.
Okay. All right. So y'all help Mohammed. Which side is this? Which side is this one? The 532. That's the adjacent side, right? Is that ringing a bell, Mohammed?
Yeah.
Yeah.
So
right.
adjacent and opposite.
So this side would be which one? Which is the height of the tree? That would be which side?
Opposite.
Opposite. That's the opposite, right? So for the angle, we're looking for the opposite length. So we have to think about which trig ratios involve the opposite side, right? Okay, Mohammed. So just go through that. Just go through that list. Sine is what? What's the basic definition of sine?
Sine is
which side over which side?
Opposite over adjacent.
No, it's opposite over hypotenuse. Yeah, opposite over.
Oh yeah, right. Sorry.
So that's sine is a possibility, right? Because we have it involves the opposite side, which we're looking for, but unfortunately it involves the hypotenuse, and we don't have any idea what the hypotenuse is, right? Okay, that's this length here in the picture, and we don't know that, right? Okay, so probably sine is not going to be very helpful to us. What else involves opposite? Which other one?
Tangent.
Tangent, right? Yeah. What's tangent now, Mohammed? What's the definition of tangent? That's what?
Opposite over adjacent.
Opposite over adjacent. Yeah, right. Okay. But look in this picture. Opposite is 8 and adjacent is this one, 532. Oh, we know the 532, right? Okay. That's not a mystery to us like the hypotenuse was. So you see, that's a good candidate for us to use to solve this problem. In fact, let's write down that equation. So we know that the tangent of this angle, 25.7 degrees, is the opposite in this picture, which is called H, over the adjacent, which we know is 532. See, so now you've got this beautiful equation, right? That just has one unknown in it, because you know the tangent of 25.7 degrees. Well, the calculator knows it, right? So soon we're going to write that down. The only real unknown here is the H, and that's the one that we're solving. All right. So again, guys on Zoom, what was the tangent of 25.7 approximately? Someone from Zoom, what'd y'all get for tangent of 25.7 with your calculator? Make sure it's in degree mode. What does that work out? What, Fernando?
0.48.
0.48. Okay. So we have 0.48 is H over 532. And now we can just solve this equation by cross multiplying, right? So multiply here, multiply here. This is, you can think of this as 0.48 divided by 1. in order to do the cross multiplying. So that's convenient. We have 1 times h is equal to 0.48 times 532, which is, what's 0.48 times 532? It's about half of 532. What does that turn out to be? What did that turn out to be?
255.36.
Fernando got 255 point what? 3.4 about? Did y'all get something slightly different? Did y'all get that? Oh, so Jad got 256, still close. All right, anyone got something different than that? Okay. All right, so I think that's it. That's 200 and about this many, 255.4 feet. Okay. Oh, does that make sense now? Okay. Mohammed, you see that now? Just a matter of remembering your just basic facts about trig, right? Okay. Well, we're going to try another problem like this one. Okay. Except it's a very similar problem, except it involves a flagpole instead of a tree. Okay. So let me switch to the next set of notes. If I can find the next set of notes here. All right. So here's the picture now. So we have a person standing on a hill a distance away from the flagpole, and we'd like to know, but we know in this case how tall the flagpole is. That is 60 feet, okay? And what we'd like to know, though, is what's that person's straight line distance to the flagpole, all right? So, you know, if they walk, they're going to walk down this hill, right? So not that distance, but just this, just that line of sight distance from the person to the, from the person here to the, from the person to the flagpole. Okay. All right. Now, here's what we, but now there's another piece of information here that's really important. Okay. We know the angle of elevation and also the angle of depression from that person to the top of the flagpole. This is 15 degrees. So this is the angle of elevation from their line of sight to the top of the flagpole. That's 15 degrees. But this angle of depression from their line of sight to the base of the flagpole also is 15 degrees. Okay. So they're kind of, in a sense, right, their line of sight there is kind of halfway up the flagpole, right? Because this angle of depression down to the base of the flagpole is 15 degrees, and this angle of elevation up to the top of the flagpole is 15 degrees, right? Okay, they're standing on a hill, so that's why you have this angle of depression to the base of the flagpole. And now what all we want to find is what's that that straight line distance, you know, their line of sight from the person to the flagpole. Okay. What's their straight line distance away from the flag? So in other words, in this picture, we're looking for X. Okay, so well, we have a couple of right triangles there, right? Okay. You have a right triangle formed here with the flagpole. If I can get this to right. So we have this triangle formed here with the flagpole, right? There we go. Exactly. All right, come on, Tim. I have lost my. I walked away with the pen. That was the problem. Huh? Yeah, I don't know how to reconnect. I think I have. Let's see. See if this will. There we go. All right. So we have this 90-degree angle, right? Okay, and same here, right? So we have a couple of triangles, right? And but fortunately, both those triangles are identical to each other, right? Okay, they involve exactly the same angles. So that gives us some clues about the sizes of the some of the sizes of the sides here in the triangle, right? What do we know about these lengths? These lengths. I'm talking about this length and this length. The half of 60, that's right, okay? Because both of these angles are 15 degrees, right? Okay, so these two right triangles are exactly the same, which means these two lengths must be the same. And so that means they're both half of 60. So this length is 30, right? And oh, this is going to be hard to get. This length is 30, and this one also is 30 as well, right? Okay. So can y'all do that then? Can y'all find X based on that information? That should be pretty easy, right? Okay. So you guys at home also there, find there for me X. There we go. Ah. So what did y'all? This thing I got to work in there. So what did y'all find there for? All right, so what did y'all get there out of that picture? What trig ratio there was easy to use? Tangent, right, again, right? So tangent, again, as I mentioned, is a favorite for us because it doesn't involve the hypotenuse, right? So what was the equation there involving tangent? Yeah, easy there, right? Tangent of 15 is going to be 30 over x, correct? And now easy to solve that for x, right? What is the tangent of 15 approximately? 0.27 or 268, approximately 27, right? Is 30 over x. And now let's cross multiply again. So 0.27 times x is equal to 30, right? The 0.27 times x, and then 30 times this implied denominator, which is 1. So finally we get x is equal to what, 30 divided by 0.27 approximately? How much is 30 divided by 0.27 about? What? 111.9 or 112 about, round off? Is that right? Okay. So our distance there to the flagpole is about 112. I guess it's feet, right? Approximately. Okay, now let's make it. Remember, you got 111. That's about right. Okay. You just rounded off slightly differently. All right, so that gave you a slightly different result. Now I'm going to make it harder still. But still a trig problem. Let's assume now that the angle of elevation and the angle of depression are not the same. Okay, all right. So so the angle of elevation is 18 degrees, and the angle of depression, though, is only 14 degrees. So that means these two right triangles are not identical, right? Okay, these two right triangles are not identical. And so that's going to make things a little bit tougher for us, because we cannot assume that this is 30, the top half of the length, the side of this triangle is 30, and the side of this one is also, right? Because these two angles are different. So see how we can solve this problem. Okay, here's where this is where algebra now is really going to be useful to us. All right, I'm still going to write down a value for this top half of the flagpole. Okay, but I cannot assume that it's exactly 30 degrees. It's exactly 30 feet. Okay, so I'm just going to give it a variable name. All right, so this length of this side. In other words, from this point of the flagpole up to the top, this side of this right triangle, let's just give that a variable name, since we don't know its exact value. Y'all want to pick out a name for that? Q. Okay, that's fine. All right, Amanda. So we'll put Q there is the top half. Now, I know the bottom half cannot be exactly Q, right? In fact, it looks like, is it going to be a little bit more or less than Q? Less. Why less? Just from the picture, why less? Yeah, that's right. This angle, 14 degrees, this angle is 18 degrees, right? So this length is going to be a little bit more than this one. But Evan, I still need to write down some expression for this bottom length, okay? Or it's going to be convenient for me to write that down. Okay. Now I don't want to use another variable though, because I mean I could call this now W or some other variable, but I want to avoid introducing variables that I don't need to introduce, because the more variables you introduce, the more unknown things you've got right in the problem, and that just complicates your life. Okay. Is there some way, Evan, for writing down an expression for this bottom length where I don't have to just make up another variable. There you go, right, okay. Isn't that right, Amanda? Okay, if this is Q, as you said, then this length has to be 60 minus Q, right? Okay, because when you add these two together, obviously, what are you going to get there? 60, right? Okay, so take Q and add 60 minus Q to it, and the Q's cancel, and you get 60. All right, so now I do have at least some quantity to work with, right, for these two things. All right, now how has that helped me? Well, we're going to see. Maybe it hasn't helped me at all, but let's see if it's helped us. Okay, because now I'm going to write down the same equations involving trig that I did for that first problem, except now I'll have two of them because I've got two different triangles here. All right, so that's what I want you to do now. Write down for me an equation from the top triangle that you could use to find x, and then write down an equation that you could use to find x from the bottom triangle. All right, okay. So an equation that involves trig that we could use to find x for the top triangle, and then one from the bottom triangle. All right, just write the equation down. Don't worry about trying to solve the equation. We won't be able to solve the equation yet. Okay, let's just try to write it down and see what we get. And then once we get that, we'll think about what we're going to. Once we get that, we'll think about what we're going to do with it. Man, I didn't leave myself much room here to work with, so. So you guys write those two down and then just tell me what they, write those two down and then just tell me. Okay, so I want someone at Zoom there to tell me an equation that came from the top triangle that we could use to perhaps use to find that value for x. So just like we did in the previous example. Okay, so an equation involving a trig ratio that also involves x, in other words, is what I'm essentially what I'm asking for. Someone at home, can y'all do that? I'm going to call on someone. Pooja, can you do that for me? Are you there, Pooja?
Yes, I'm here.
Okay, so can you write down an equation involving a trig ratio that also involves x? Ideally, I'd like to be able to solve the equation for x, but not going to quite be able to do that initially. So, so what can we put down, Pooja? I mean, from this triangle, the top one. I mean, we have 18 degrees. We have a name for this side. We have a name for Q. We have a name for this side X. So what equation can we write down? So you have the 18 degrees, Pooja. In terms of the 18 degrees, what is this side? Is that the hypotenuse? Is that the, which side would this be? What's confusing you there? Pooja, what's confusing you? All right, Pooja, are you there, Pooja? Yes, no? Did I lose you completely? Do I even see Pooja there? Is Pooja on that list? Is this her? This might be her. No, that's Fernando. Okay, well, we've lost Pooja. Let's try someone else at home that can write down this equation. Christian, can you write it down for me?
Is it Christian or Christopher?
Well, Christopher, you'll do too. Okay. I'm looking at volunteers.
Well, I don't know if it's right though, but I got tangent 18.
Right. So tangent what?
18
Yeah.
equals
Uh-huh.
Q over X.
Perfect. That's all that I'm looking for. Right. Okay. Tangent of 18 is equal to Q over X. That's beautiful, Christopher. Now, see, Christopher, the problem with this equation, though, is we don't know, unfortunately, of course, we'd like to know X, right? If we knew X, we'd be done because that's what we're looking for here. So obviously we don't know X. Unfortunately, we don't know Q either, right? Remember in the first version of this problem, we knew that Q was 30 because both of these links were the same. But here, we don't know the value of Q, we just have Q. So now, but we do know tangent of 18 degrees because that we can get from the calculator, see, okay? So this is not an unknown, but these two things are unknown to us. So unfortunately, we have this equation with two unknowns. That means we're not going to be able to find either Q or X, unfortunately, from this equation. All right. So, you know, we're still hard at work here, right, Christopher? But Christopher, let's write down the same or a similar, it's not going to be exactly the same, but a similar equation for the bottom triangle. Can you tell me an equation similar to this for the bottom triangle?
Yeah. Tangent 14
Tangent of 14, right, is
equal
equal to what?
60 minus Q over X.
60 minus Q over X. Okay. Now this equation has the same problem as this one because this equation also has two unknowns in it, right? Okay. So I'm not going to be able to solve for either X or Q, but all right, now we're in much better shape because now we have these two unknowns, X and Q. We don't know either one of them. With one equation, we would be stranded. But when you have two unknowns, if you have two equations that involve those unknowns, then you have a chance of finding the values of those two unknowns, okay? So the secret is when you've got multiple unknowns, you need multiple equations. Typically, you need as many equations as you have unknowns. Well, we're in good shape here. We've got two unknowns, X and Q. X is the only one we're really interested in is X, right? But we're going to solve it. We're going to find Q also. But we've got now two equations, you see. So now we have a chance for finding good X. Now the question is, how do I do that? All right. All right. So here's how. All right. Look, first, these are not unknowns to us, right? We know what the tangent of 14 and the tangent of 18 is according to the calculator. So let's fill that in. What is the tangent of 18? A couple of decimal places is plenty.
0.32.
What'd you say? 3. So about 0.33, okay, is Q over, that's equal to Q over X, right? And what's tangent of 14 degrees? What now? Oh, 0.25, okay. So that's equal to 60 minus Q over X. So now, if you cross multiply here in this equation, I'm running out of room, but let me squeeze it in. If you cross multiply in this equation, you'll get Q is 0.33 times X, right? Now, you know, by itself, that's not that great, right? Because I don't know X, so I'm not going to know what Q is. But now you can take the 0.33 times X and you can substitute it for Q over here, right? So take that expression, 0.33 times x, and in the second equation, plug that in for Q. Wow, what does that give us? Let's see, do I have enough room now to write that down? I have 0.25 is equal to 60 minus 0.33x over x. How many unknowns now does this equation have, though? 1. Right, okay. That equation now is down to 1 unknown. See, so you see, I use that first equation, right, to get rid of the variable q in the second equation. And now I have just this equation with 1 unknown, which now I can solve. Hopefully, right? Might be tough, but at least I have a chance of solving that. This one's not tough at all. What can we do here, of course, to solve? What have we been doing all along to solve these equations? Cross multiply, right? So take the x times the 0.25. That implied denominator for the 0.25 is 1. So you multiply 1 times that numerator on the other side. Wow, you get an easy equation. 0.25x is equal to 60 minus 0.33 times x. I know we can solve that. So y'all solve that x. Tell me what that is. Got to do it quickly here, but that's pretty fast. So you guys at home also, right? Try solving this for x. And give me what that is approximately.
I got 103.4.
103 point what?
44 or 45.
Okay, so either 0.4 or 0.5, right? Okay. We get
Yeah, whatever you want to round it
slightly
to.
different rounding there, depending on who is doing the calculations. All right. So there it is, right? X is about 103.5, close to the answer in the previous problem, right? But slightly different because, of course, the angles there were slightly different. So here, that straight line distance is only 103.5. Okay. Cool. See, right? So there we solved the surveying problem, but using our trig. Okay. Well, use trig a lot in surveying problems. Okay. All right. Well, there's our first 2 applications there, or 3 applications there of our trig knowledge. There's lots of these in the first homework we're going to have about trig. Now, next time, we want to, as I mentioned, in these applied problems with right triangles, you only have angles between 0 and 90 degrees. But in other applications of trig, we need to be able to compute trig ratios for angles larger than 90 degrees and also negative angles as well. Okay, so next time we're going to talk, how do you define trig ratios for angles larger than 90 degrees, or 0 or 90 degrees also, and for negative angles, because those angles cannot be embedded in a right triangle. So the idea of opposite and adjacent and hypotenuse don't make sense for larger angles or negative angles, right? So how do we define trig ratios for different size angles? How does that work? Okay, we're going to talk about that next time. Okay. All right. So I'll see you on Wednesday. So be studying for your, don't forget about studying for your tests. I think the homework that's due tomorrow, I'm going to delay it to Wednesday. So the functions homework will be due Wednesday. I'll see y'all on Wednesday.